Generative AI is absolutely everywhere right now. It's the ultimate buzzword, isn't it? Constantly making headlines.
Oh, definitely. You see those incredible images, the new tools popping up left and right.
Exactly. But for all the hype, what is it really?
Hmm.
And, how does it actually perform its magic?
That's precisely what we want to tackle in this deep dive. We're aiming to cut through all that noise.
Okay.
We'll unpack exactly what generative AI is, how it stands apart from other kinds of artificial intelligence,
Yeah.
dive into the, frankly, fascinating technology that makes it work, look at its applications, which are incredibly wide-ranging,
Right.
and crucially, address its real-world impact and the critical considerations for developing it responsibly.
So the goal here is to leave you, our listeners, feeling genuinely well-informed, maybe with some surprising insights along the way.
That's the plan, and we've pulled from some really great sources. Google's own intros to generative AI, detailed research from places like MIT, Stanford, Google Research,
Top-tier stuff.
insights from firms like Deloitte, too, and even a breakdown of this interesting parameter called temperature in natural language processing.
Okay. Sounds like we're well-equipped.
Yeah.
Get ready, everyone. It's going to be an illuminating journey.
So to really get a handle on generative AI, maybe we should start with the bigger picture, the AI landscape.
Good idea. Lay the groundwork.
Think of artificial intelligence, AI, as the big, broad discipline. Like physics is a discipline within science. It's the whole field.
Right. The overarching concept of making machines intelligent.
Okay.
So where does machine learning fit in? ML.
Okay, so machine learning ML is a subfield within AI. It's where models learn from data to make predictions. The key is they do this without being explicitly programmed for every single task.
They learn from examples, basically.
Exactly. And then deep learning takes that a step further. It's a type of machine learning using artificial neural networks.
Inspired by the human brain, I've heard.
That's right. Which lets them process much more complex patterns in data. And here's where it gets really relevant for us. Generative AI, it's actually a subset of deep learning.
Oh, interesting.
And so are large language models, LLMs, which you hear so much about, also a subset of deep learning.
So generative AI is nested pretty deep in that AI family tree.
Yeah.
Okay, if ML learns from data to predict, what does the generative part actually mean? What's different?
That generative bit is really the core of it. Generative AI is specifically technology that produces content.
Produces,
Yeah.
like makes new stuff.
Yes. Text, images, audio, even synthetic data. It creates entirely new content. It does this by learning the underlying patterns and structure from existing data.
Right.
First, that's the training process.
Okay.
Then it uses that learned statistical model to predict and generate totally new, unique samples.
Okay, that sounds fundamentally different from, say, an AI that just recognizes faces in my photos.
Exactly.
That AI tells me what is. This sounds like it makes what isn't yet.
Precisely. We can contrast it with what we call discriminative models. Those are the ones used to classify or predict labels, like saying dog or cat for an image.
Right.
A generative model, on the other hand, generates new data instances. It learns the probability distribution of the data and creates something fresh from that. It doesn't just label, it originates.
That distinction really highlights a massive shift, doesn't it, in how we interact with computers. I mean, think about the progression.
Yeah.
Traditional programming. You had to hard code everything. Define a cat. 4 legs, pointy ears, likes yarn.
Yeah.
All spelled out.
Right. Very explicit rules. Then came neural networks, where you could show it pictures and ask, is this a cat? And it gives you a probability.
A prediction. But now, with this generative wave, we're moving beyond just identifying or predicting.
Absolutely. We as users can now generate our own content.
Just by asking.
Pretty much. Text, images, audio, video, you name it. Simply by prompting the model. It's a totally different way of interacting. A paradigm shift, really.
Okay, let's dig into the how then. What's under the hood? What's driving this magic?
Well, a huge part of the power comes from transformers. It's a specific type of neural network architecture invented back in 2017.
Transformers, right? Heard that term. What makes them special?
They have this mechanism called attention. It allows the models to weigh the importance of different words or data points in a sequence, even over long distances. They can pay attention to context.
Ah, so they understand how things relate,
Yeah.
even if they're far apart in the text or data.
Exactly. That's crucial for generating coherent, contextually relevant output. It's foundational.
Okay. And building on that, we hear a lot about foundation models. What are those exactly? Why are they such a big deal?
Good question. A foundation model is basically a very large AI model that's been pre-trained on a massive amount of data. Think huge data sets.
Okay, pre-trained, meaning it's got a general education.
Sort of, yeah. They are specifically designed to be adapted or fine-tuned for a whole range of downstream tasks.
Like what kind of tasks?
Oh, things like sentiment analysis, captioning images, recognizing objects, translation, writing code, lots of stuff.
So they're like a versatile base layer you can build specific skills on top of?
That's a great way to put it. And if you think bigger picture, these foundation models could genuinely revolutionize industries. Healthcare, finance. Imagine fraud detection, personalized customer support.
The potential seems enormous.
It is, and you see platforms like Google's Vertex AI offering a model garden with these types of models ready to go, language, text, code, vision models like Stable Diffusion for making images from text.
That adaptability is incredible. But how do they learn new things so quickly, sometimes without massive retraining? I've heard this term in-context learning. What's that about?
Ah, yes, that's a really fascinating and frankly somewhat mysterious phenomenon. Researchers notice that these big language models can often perform a new task after just seeing a few examples.
A few examples, not like thousands.
Right, just a handful. And here's the kicker. Without needing new training data or actually updating their underlying parameters.
Wait, how is that possible? If the parameters aren't updated, how is it learning?
Well, this is where it gets wild. Recent research suggests these huge networks might actually contain smaller, simpler models hidden within their layers.
Like models within models.
Kind of. And the larger model might be able to implement simple learning algorithms internally to train these smaller models using only the information it already possesses from its initial training.
So it's like the big model teaches little mini models inside itself on the fly. That sounds almost like self-improvement.
It's been described as an unreasonably efficient learning phenomenon. We're still figuring out the exact mechanisms, but it's a major area of research.
Mind-blowing stuff. Okay, so we want the model to generate, say, a really creative story versus just a factual answer. How do we control that?
That's where a parameter often called temperature comes into play, especially in natural language processing.
Temperature, like hot and cold.
Metaphorically, yes.
Yeah.
You can tune it to increase or decrease the model's confidence in its most likely prediction versus exploring less probable options.
Okay, so higher temperature means.
Higher temperature makes the model take more risks, essentially. It becomes more creative, more random, exploring less likely word choices. Great for generating poetry or fiction.
And lower temperature.
Lower temperature makes it stick closer to the most probable, predictable outputs. It becomes more confident, more focused, which is useful for things like question answering or summarization where you want accuracy and consistency.
That makes perfect sense. A dial for creativity versus precision. Okay, let's pivot to the real world. Where are we seeing all this technology applied? And maybe touch on some of Google's specific contributions.
Absolutely. The applications are spreading fast. We're seeing generative AI generate text, code, images, audio, even video now.
Focusing on language first, what can these models do?
A lot. They can create natural-sounding text, generate really creative content formats, translate languages fluently, help programmers write and debug code, and of course, answer complex questions conversationally.
Google's been big in this space. I remember LaMDA making waves. What was its significance?
LaMDA, language model for dialogue applications, was really a breakthrough in conversational AI. It was trained specifically on dialogue, which made its responses much more sensible, specific, and, well, interesting in a back-and-forth conversation.
Moving beyond just question answering to actual chat.
Exactly.
Yeah.
Then you have models like PaulM, 540 billion parameters, just a massive scale.
What did that scale enable?
PaulM showed incredible performance across a wide range of tasks: language understanding, translation, coding, even tasks it wasn't specifically trained for. It demonstrated strong generalization. Plus, it made strides in translating low-resource languages, which is huge for accessibility.
And the latest big one from Google is Gemini, right?
Yeah.
That one seems like a major step forward, being multimodal.
It really is. Gemini is the first model to actually outperform human experts on a key benchmark called MLU that covers 57 subjects, everything from math to ethics.
Wow, outperform human experts.
On that specific massive multitask benchmark, yes. It also excels in coding, powering the AlphaCode 2 system, which did better than 85% of human competitors in programming contests.
That's seriously impressive. And the multimodal part is key too.
Absolutely crucial. That's the next frontier. Gemini can understand and reason across different types of information, simultaneously text, images, audio, code.
So it can look at a picture, listen to audio about it, read text, and understand it all together.
Yes, allowing it to handle much more complex, nuanced tasks than previous models could. Think analyzing complex charts and the text explaining them.
That leads us into vision and these multimodal interactions. We're seeing AI generate images from text prompts.
Definitely. Models like Imogen and Party from Google Research create incredibly high-resolution, detailed images just from text descriptions. And it goes the other way, too. AI looking at an image and generating a text description, captioning, or answering questions about it, visual Q&A.
And video generation's coming along too.
It's a harder challenge maintaining consistency over time. High resolution, but models like Imogen Video and Funaki are making real progress.
And this combining of senses, like with Gemini or another Google model, Parallel,
Right, Pala is another great example, a unified language image model. Trained in over 100 languages, it can do visual question answering, image captioning, object detection, all within one model. It really bridges the gap between vision and language understanding.
it feels like these multimodal models are getting closer to a more human-like understanding of the world.
They're certainly integrating information in more sophisticated ways. And importantly, Google is also providing tools to help developers and businesses actually use these powerful models.
Like Vertex AI Studio.
Exactly. It lets people explore, customize, and deploy these generative models more easily. It offers pre-trained models, tools for fine-tuning them on your own data, and resources for putting them into production.
And for those without coding skills.
There's Vertex AI Agent Builder. It's designed to help people build things like chatbots, custom search engines, or digital assistants using generative AI, even with little to no programming background.
Lowering the barrier to entry. That's key for broader adoption.
Definitely. Okay, let's shift gears a bit. Beyond the cool tech, what about the wider impact, particularly on the economy, on jobs? This is where it gets really interesting.
Yeah, the productivity question. Does this tech make everyone instantly better at their jobs?
Well, it's nuanced. Previous tech waves often boosted high-skill workers the most. But generative AI, it might be doing something different.
How so?
There was a fascinating study looking at customer service agents using a generative AI tool. And guess what? It significantly increased the productivity and even retention of the newer or lower skill workers.
Really? Not the experienced ones.
The lowest skill group saw a 34% jump in resolutions per hour. Agents with less than a month on the job improved by 46%. For the high-skill, experienced agents, the impact was minimal, sometimes even slightly negative on quality.
Wow, that completely flips the script. It's
Yeah.
like an equalizer, helping less experienced people get up to speed faster.
Exactly. The study also found customers treated agents better when the AI assist was used, and fewer agents quit.
That's incredible. So maybe it's not about replacing people, but augmenting them,
Yeah.
especially those who need the most support.
That seems to be a key finding. Think about analogies like the drum machine in music.
Didn't replace drummers, just created new possibilities, new genres like hip-hop.
Precisely. Or the graphing calculator in schools. Didn't eliminate math, but changed how we teach and assess it, demanding students show their work differently.
So generative AI is a tool that enhances capabilities and changes workflows, rather than just a simple replacement.
That's a great way to frame it. But of course, with such powerful technology, there are significant risks and challenges we absolutely have to address.
Right, the responsibility aspect. What are the big concerns?
One major one is hallucinations and misinformation. These models can sound incredibly confident while being completely wrong.
They just make stuff up.
Sometimes, yes. They might invent facts, sources, citations. It's crucial to remember that coherent output doesn't automatically mean valid output. Critical thinking is still essential.
Very important point.
That
What else?
bias is a huge concern. These models learn from vast data sets, often scraped from the internet.
Which reflects all the biases already present in society.
Exactly. So the models can inadvertently internalize and even amplify those biases related to race, gender, stereotypes, etc. Ensuring fairness is a massive challenge.
And what about originality? If the AI generates something, who owns it? Attribution and IP.
That's a thorny legal and ethical area. Outputs can sometimes resemble existing works without clear attribution, raising worries about plagiarism, copyright, trademarks. The key principle being developed is that a human must be accountable, not the AI itself.
Right, the tool doesn't have agency. The user does.
And related to all this is transparency and explainability. How do these incredibly complex black boxes actually arrive at their outputs?
Especially for the average user, right? How can they trust it if they don't understand its limits?
Exactly. Simple disclaimers saying AI generated this often aren't enough. We need accessible, non-technical ways to explain what the models can and can't do and where potential pitfalls lie to build genuine user trust.
It's good to hear that major players like Google are thinking about this proactively. They have AI principles, right?
Yes, since 2018. They focus on things like beneficial use, safety, avoiding unfair bias, being accountable, incorporating privacy. It's a framework for responsible development.
How do they put that into practice?
Through things like internal governance structures, applying rigorous scientific methods, collaborating with diverse experts, including social scientists, ethicists, actively seeking external feedback, regular safety reviews, and working with others to shape responsible regulations globally.
So it's an ongoing, multifaceted effort, not just a checklist.
It has to be. The technology is evolving so fast, the approach to responsibility needs to evolve too.
We have definitely covered a lot of ground today. From the absolute basics, what generative AI even is, its roots in deep learning,
To the core technologies like transformers and foundation models, that weirdly cool in-context learning.
right, and then its real-world impact, both the amazing applications and the productivity shifts, but also the critical need for responsible development. Hopefully you listening now feel like you have a much clearer picture.
So, thinking about all this, what does it really mean for your future? Because generative AI isn't just another piece of software. It feels like a fundamentally new way to interact with information, with creativity itself.
That's the big question, isn't it? How will you use these powerful new capabilities responsibly, creatively? What new languages might we all need to learn to truly partner with this evolving intelligence?